Hey guys, welcome back to my channel. Today we're going to do a video on surface area and volume combined with 3D trigonometry. In these questions, you will come across like different types of shapes where they're asking us to use 3D trigonometry to figure out what the volume or the surface area of a 3D shape would be. This is a part of the series for IGCSE Edexcel Maths 8 topic questions for higher. If you check out the playlist above, you will come across different videos for different topics, and in each video, we're using past paper questions from 2018 onwards. So let's start with this one and see how we can incorporate 3D trigonometry in volume and surface area to find the missing information. So we have a cuboid A, B, C, D, E, F, G, H. AB is given as 5, AH is given as 4, and the size of the angle between CH and the plane ABCD is 35. So CH is this, and this angle over here is given as 35. We have to calculate the volume of the cuboid. So as you can see, for the volume of the cuboid, we need the length, the width, and the height. We have the height, we have the length, we don't have the width. So how do we figure out the width? For the width, if you notice, if we use the right angle triangle AHC, we can first figure out AC, and then using AC and AB, which is another right angle triangle over here, we can figure out BC. And once we have BC, we can easily find the volume of the cuboid. So first, using triangle AHC, we have an angle, we have a length, we need to find the adjacent over here. So we will use SOHCAHTOA. Since we have the opposite and adjacent, we use tan. Tan 35 equals to 4 over AC. So AC is going to be 4 over tan 35, which gives us a value of 5.71 centimeters. Now, if you look at the triangle ABC, we have the hypotenuse, which is 5.71. We have the other leg. We have to find the length of BC. So when we have two lengths in a right angle triangle and we're trying to find the third one, no angle is given, we use Pythagoras theorem. So 5.71 squared equals to 5 squared plus BC squared. 5.71 squared minus 5 squared equals to BC squared. So 5.71 squared minus 5 squared gives us 7.6041. Then we will square root both sides. That's going to give us 2.763 centimeters equals to BC. So volume is going to be 4 times 5 times 2.763. That gives us 55.26. We want the answer correct to three significant figures. That's 55.3 centimeter cube. That is your volume of this cuboid. As you can see, they mixed 3D trigonometry with the volume of a 3D shape. In 3D trigonometry, you will use SOHCAHTOA or Pythagoras based on the type of information that's given. Then since the diagram shows a solid prism ABCDEFGH, the trapezium ABCD in which AD is parallel to BC is the cross section of the prism. The base ADEH of the prism is a horizontal plane. ADEH and BCFG are rectangles. The midpoint of BC is vertically above the midpoint of AD, so that BA equals to CD. So this and this are equal. So it's like a symmetrical shape. And AD is 37, GF is 28, DE is 24. The perpendicular distance between edges AD and BC is given as 20. We have to work out the total surface area of the prism. This would be 28. This would be 24. So for the total surface area of the prism, They've given us this perpendicular height as 20. It's a right angle. So what's missing is these side lengths. We don't have that. That's what we need to find. So in order to find that, we can see that we will use this right angle triangle, ABX, let's call this X. We know this is 28 BC and AD is 37. So to find the remaining length, AX, we do 37 minus 28 divided by 2. The reason why we're dividing by 2 is because it says that the midpoint of BC is vertically above the midpoint of AD, and that makes AB equals to CD, which means the shape is symmetrical. There's one line of symmetry. So AX would be 37 minus 28 divided by 2. That's 4.5. So this is 4.5. We can use this right angle triangle to figure out the length of AB. We can use Pythagoras because we have two lengths and the third one is missing. So AB squared equals to 4.5 squared plus 20 squared. That's going to give us 420.25. Then we will square root both sides and AB turns out to be 20.5 centimeters. Now that we have AB, we can easily find the total surface area of this prism. Let's begin with the base. That's going to be 37 times 24. Then we do the side faces. That's going to be 20.5 times 24. Let me just write this here. This is 20.5. And we will multiply this by 2 because we have two faces of the same measurement. Then the top part, 28 times 24. And then we have two trapezium faces at the cross-section area. So 1/2 times 20 times sum of the pile sides, which is 28 plus 37. And then we times 2 because of the two trapezium faces. That gives us 3,844 centimeters square. That is the total surface area of a prism. So as you can see, we once again used 3D trigonometry over here to figure out the missing lengths and then use that to find the total surface area of this prism. Then it says calculate the size of the angle between AF and the plane ADEH. Give your answer correct to 1 decimal place. So now if you notice, they want the angle between AF and the base ADEH. So if I make a line from A to F, this is a right angle triangle over here. We know this length over here is also 4.5 because the prism faces are identical for the cross-section area. And this would be 37 minus 4.5, this length. So this length over here, let me call this M. So HM is going to be 37 minus 4.5, which is equal to 32.5 centimeters. So if we use this triangle AHM, let me just draw it out over here. This is in the base of the shape. H A M. So MH is, or HM is 32.5. AH is 24. We need to find AM because that is the base of this right angle triangle over here, AFM. So we use Pythagoras. AM squared equals to 32.5 squared plus 24 squared. So 32.5 squared plus 24 squared That gives us 1632.25. Then we will square root both sides, and AM equals to 40.401 centimeters. So now that we have the base of this triangle, let me sketch this out over here. So that is M, A over here, and F over here. We have AM, 40.401. We have FM, that's going to be 20. We need to find this angle over here. So we'll use tan theta equals to 20 over 40.401. That's tan inverse of 0.49503, and that gives us 26.3 degrees. That's your angle that the length AF makes with the base of the shape. So for this, you need to use the measurements that you found in the previous part. This part over here, we cannot make it a complete right angle triangle like we did initially. It's like in the middle of the length. So it's in the middle of the length, we need this part over here to figure out the base of the triangle because there's no way of finding AF. So you just have to use the information that you've already found, plot it neatly and see. And also I would suggest try making these triangles that you're making inside the 3D shape separately like I've drawn. This way it lets you allow to see a more clearer picture of what you're trying to solve and how you can solve it. Then it says the diagram shows the cross section of a circular water pipe. OABC is a sector of a circle center O. The shaded region in the diagram represents the water flowing in the pipe. The water flows at 14 centimeters per second in the pipe. Work out the volume of water that has flowed through the pipe in 3 minutes, giving your answer in centimeter cube correct to 3 significant figures. So if O is 4.8, OC is also going to be 4.8 because they're both the radius of the circle, like the circular pipe. First, we need to figure out the volume of the water. For the volume of the water, we need to figure out the area first. So you find area of the triangle OAC, then you find the area of the sector OAC, subtract the two to get the shaded area. So let's start with that. Area of sector. That's going to be 72 divided by 360 times pi times r squared. That gives us 14.476 centimeters squared. Then you find area of the triangle. That's going to be 1 over 2 times 4.8 times 4.8 times sine of 72. That equals 10.956 centimeters squared. Shaded area is going to be the difference of the sector area and the triangle area. That gives us 3.52 centimeters squared. Now it said that the water flows at 14 centimeters per second in the pipe. Work out the volume of the water that has flowed through the pipe in 3 minutes. So for 1 second, it's flowing 14 centimeters. So for the volume, we will multiply the shaded area with the flow of the water per second. And then since we want to find the flow for 3 minutes, 1 minute has 60 seconds. So for 3 minutes, it's going to be 3 times 60. So you multiply all of this, and what we get is 8,870 centimeter cube. That is the volume of the water flowing through the pipe in 3 minutes. The frustum is made by removing a small square-based pyramid from a similar large square-based pyramid as shown in the diagram. So the best thing about this question is that they've highlighted themselves that they're similar. in most questions, what happens is that they don't highlight that it's made from a similar base. So you need to easily know what to do now. If it says they're similar, we use the concept of similar shapes over here to figure out the missing information. The height of the small pyramid is 15 and the height of the large pyramid is 45. The square base of the large pyramid has length 39 centimeters. We have to work out the total surface area of the first one over here, giving your answer correct to the nearest whole number. So using the concept of similar shapes, I'm going to first figure out the base of the removed pyramid. So H1 over H2 equals to B1 over B2. So H1 is 15, H2 is 45. H1, H2. This is B2, B1 is what we're trying to find. B1 over 39. Cross multiply, 15 times 39 over 45. And that's going to give us 13 centimeters. That is your dimension for the base of the removed pyramid. So 13 and 13. So first, let's find the area of the faces that we can. We have the dimensions for the top part and the bottom part of the first term. So top is 13 times 13, which is 169 centimeters square. And the bottom is 39 times 39, which gives us 1,521 centimeters square. Now about the sides. For the sides, if you notice, the original shape was a pyramid, and from that pyramid, we removed another pyramid. So what if we use the side faces as the complete triangles, find the area of the original triangular face of the large pyramid, then of the removed pyramid, and then subtract those to get the area of the side face of the frustum. So for that, this is your triangle. We have the base for both of them. What we need is the perpendicular height. So that perpendicular height is basically the slant height of the pyramid. So if we half 39, 39 divided by 2 is 19.5. We have this, we have the original height, and over here half would be 13 divided by 2, just 6.5. So if I draw both the triangles separately over here, you'll get a better idea. So for this small one, let me write that. This is our triangle with the base of 6.5 and height of 15. We need to find this slant length. So we'll use Pythagoras. X squared equals to 15 squared plus 6.5 squared. So that's going to be 267.25. Square root both sides, 16.347 centimeters. That is the slant length of the small triangle, like from the small pyramid. Now we use Pythagoras again to figure out the slant length of the large triangle. So that's going to be y squared equals to 45 squared plus 19.5 squared, which gives us 2,405.25. We will square root both sides, and y would be 49.04 centimeters. Area of small triangle, that's going to be 1 over 2 times the base was 13 and the height was 16.347. That's going to give us 106.256 centimeters squared. Then area of large triangle, that's going to be 1 over 2 times 39 times 14.04. That equals to 956.28 centimeters square. So area of frustum side face would be the difference of these two. So 956.28 minus 106.256, and that gives us 850.024 centimeters square. So now for the total surface area of the frustum, we will multiply this by 4 because there are 4 faces, and then add the initial areas that we found for the top and bottom, which was 169 and 1521. So when we add these up, what we get is 5090.1 centimeters square. They want the answer correct with the nearest whole number, so that's going to be 5090 centimeters square. That's your answer. So for this, don't get into trying to find the area of the trapezium, like because the side faces are trapezium, because it's not going to be that simple. Just stick to your basics, use the triangle, try to find the slant length, which is your basically the perpendicular length of the triangular faces. Subtract the areas, and then when you have the area of the side face of the frustum, times that by 4, then add it to the top and bottom face of the frustum. This is a diagram shows a rectangular sheet of metal ABCD. BD is given as 50 centimeters. Angle BDC is 32. Now, so join side AD to the side BC to form a cylinder. BC is the height of the cylinder now. And DC is the circumference of the cross section of the cylinder. Work out the volume in centimeter cube of the cylinder. Okay, so look, DC is becoming your circular face. So if you find the length of DC, that would be the circumference of the circular face. And BC is your height. So as you can see, we have this right angle triangle over here shown in the open sheet. So using SOHCAHTOA, we can figure out DC and BC and then further use that to find the volume of the cylinder. So first, let's start with finding BC. So we have the hypotenuse, we have to find the opposite. So we'll use sine. Sine 32 equals to BC over 50. So 50 times sine 32 is going to give us the length of BC, which is 26.495 centimeters. Then to find the length of DC, we need the adjacent, so we use cosine. So cos 32 equals to DC over 50. So 50 times cos 32, that's going to give us 42.402. That's your DC. So now DC is your circumference of the circular base. So circumference is 2 pi r. So 42.402 equals to 2 pi times the radius. Using this formula, we figure out the radius of the base because we need that to find the volume. So 42.0402. So 42.402 divided by 2 divided by pi. That's going to be 6.748 centimeters. That's the radius. So now volume is going to be pi r square h. So pi times 6.748 squared times the height, which is 26.495. That's going to give us 3790.22. They want the answer correct to 3 significant figures. So 3790 centimeter cube is the volume of the cylinder. Then the diagram shows a solid pyramid ABCDE with a horizontal base. The base BCDE of the pyramid is a square of side 10 centimeters. The vertex A of the pyramid is vertically above the center O of the base, so that AB equals to AC equals to AD equals to AE. So all of these lengths are equal. The total surface area of the pyramid is 360 centimeters square. We have to figure out the angle between AC and the length and the base BCDE. So we're trying to figure out this angle. They have given us the total surface area. So total surface area is basically your all four triangles added with the base. We don't have anything for the triangles. So using that, we can figure out the perpendicular height of the triangle, which will be the slant height of the pyramid. So 360 equals to 4 times area of triangle plus area of square. So that's going to be 4 times 1 over 2 times 10 times the height plus 10 times 10. So that's going to be 360 equals to 20h plus 100. 360 minus 100 divided by 20 is going to be h. That gives us 13 centimeters. That's your h value. Now this h value is, is this one. This is 13. So now we need the length of AC. We can find the length of AC using Pythagoras because this is a right angle triangle. This half is going to be 5. This is 13. So we can use this to find AC. So AC squared equals to 13 squared plus 5 squared. AC is your hypotenuse. So 169 plus 25, that's 194. Square root both sides, and AC is going to be 13.92 centimeters. Okay, now that we have AC, to figure out the angle, we need this length OC. So if this is 10, this is also 10. We find the diagonal EC, again using Pythagoras because it's a right angle triangle, square base. And then half of that is going to be OC. Then we use that and AC to figure out the angle. So let's start with finding EC first. EC squared is going to be 10 squared plus 10 squared, which is 100 plus 100, 200, square root both sides, and EC equals to 14.142 centimeters. OC is going to be half of EC. So that's 14.142 divided by 2, and that is 7.07 centimeters. Now for the angle, I will make the triangle again. AOC. So this was 7.07. This is the angle we're trying to find, and that was 13.92 centimeters. So we have the adjacent, we have the hypotenuse, we have to find the angle. So cos theta equals to 7.07 divided by 13.92. So cos inverse of 7.07 divided by 13.92, and that gives us 59.47 degrees. They want the answer correct to 3 significant figures. That's going to be 59.5 degrees. That's your angle. And with that, we're done with the questions for volume and surface area mixed with 3D trigonometry. I've already uploaded a separate video for finding just the volume and surface area, like the more easier and basic questions. You can check that out at the link above. And I'll be uploading the next video, which will be about volume and surface area for cones and spheres, along with like spheres and cones mixed with pyramids and cylinders, like the more complicated ones. So if you have any questions or confusion so far, please leave a comment below and I'll help you out. And if you've understood everything, please like and subscribe and share this video with your friends because it's greatly going to help in exam prep.